South of the Okanagan Valley floor, where sagebrush meets exposed silt cliffs, surface temperatures pass 45 degrees Celsius by early afternoon. On that scorched earth, a team unloads crates from a refrigerated truck and pries the lids open. Not irrigation equipment or saplings, insects. Millions of them, chilled, motionless, waking up in one of British Columbia's driest stretches. Then everyone drove away, leaving them on Crown land for a year. It sounds made up, which is the most interesting thing about it. Across Western Canada's southern dry belts, land managers genuinely ask if native pollinators can hold a fragile ecosystem together. Not transform the interior into farmland, just stop remaining native grassland from vanishing. But a honeybee colony fails above 38 degrees, and hot interior afternoons hit 40. Why does this story keep getting told? I'm Ambrose Wild, and I went looking for the study behind it. What I found was better. Every version opens the same way. Millions of bees, frozen solid, released into the interior desert in 2023, abandoned for 12 months. Some say 3 million. Some say the valley bloomed. Some say colonies cooked and the project collapsed. None say who ran it. No Canadian university, no NSERC grant, no published paper, no named researcher, no provincial permit, no monitoring data. Trace any version back, and it ends in another video with the same thumbnail, or an article assembled by an algorithm. The story has a plot and no origin. The honest place to begin isn't what happened to those bees, but why a sourceless story travels so well. A real ecological experiment leaves a paper trail before a headline, a provincial research permit, an institution, a principal investigator, GPS coordinates. This arrives fully formed, with a round number of bees, a year conveniently just elapsed, and no contact at Agriculture and Agri-Food Canada. The specifics evoke feeling, but are absent where you could verify. It travels because it flatters a common assumption that an arid landscape is broken, and a broken landscape can be repaired by adding life. Ship in pollinators. Wait a year. Watch dirt turn green. It's a satisfying shape. It's also the exact shape of 40 years of habitat restoration failure. The actual science around Western Canadian pollinators is stranger. The story uses honeybees because honeybees are what we picture. Wooden hive boxes, a beekeeper in white, frames heavy with comb. But the European honeybee is livestock, a managed, medicated agricultural animal bred for honey yield, like dairy cattle for butterfat. Releasing honeybee colonies onto Crown rangeland to rescue an ecosystem makes as much sense as releasing Holsteins into the boreal forest as rewilding. Our native habitats already have bees. They just don't look like those on the jar. Western Canada's true pollinators are overwhelmingly solitary. A female digs a nest tunnel into sun-baked silt, provisions cells with pollen, seals them, and dies before offspring emerge. No hive, no shared nest, no colony to overheat. A solitary ground-nesting bee never has to cool a communal nest through a 40-degree afternoon. That constraint kills imported commercial colonies, but native bees lack it. Many solve heat by refusing to meet it. They fly at first light, stop as the sun climbs, and return as the plateau surrenders heat at dusk. Seedlings went into compacted dirt that shed rain like concrete, dying within seasons. Land managers shifted from continuous green walls to a mosaic of microcatchments. They revived shallow microbasins, small pits punched into crusted soil packed with organic compost, alongside crescent-shaped earthen contour buns facing uphill. Neither adds new life directly. Both stop water from leaving. Heavy downpours run off hardpan quickly. A half-moon bund catches runoff, holding it so 10 to 15% recharges water tables instead of vanishing down slope. Inside the basin, sheltered by its rim, a seedling gets a cooler microclimate. Machinery now cuts microcatchments at 10 times human speed. Crescent-shaped scars in dry earth. That's the intervention that worked. Geometry, not imported pollinators. There is a real global ecological dynamic. Almost nobody repeating the bee story knows. Every year, Continental winds lift millions of tons of mineral dust off arid basins, carrying key nutrients across oceans. Dust from ancient inland lake beds travels thousands of kilometers to dense coastal rainforests, delivering tens of thousands of tons of essential phosphorus annually. Satellite instruments measuring these plumes show that this wind-blown phosphorus equals the amount lost each year to heavy rainfall and runoff in rainforests. The most biologically productive forests run a balanced nutrient account, maintained from thousands of kilometers away by the erosion of barren landscapes. The terrain that looks most barren feeds the forest that looks most alive. Seen this way, the frozen bee story is a symptom of judging ecosystems by how closely they resemble manicured farms, assuming anything else is broken. These dry landscapes have been performing their global function downwind all along. For over a century, Western settlement treated semi-arid grasslands as waiting rooms. Archival records from railway expansion describe dry belts as wasted space awaiting plows and ditches. The assumption, if a landscape doesn't look like an Ontario pasture, it's missing something. Yesterday's irrigation promoter became today's viral restoration video, promising quick fixes without requiring us to understand how the system already works. Walk into BC's bunchgrass ecosystems or southern Alberta's shortgrass prairies in July, and you see nothing is waiting. The ground is a living biocrust, complex communities of lichens, mosses, cyanobacteria, and microfungi knitting topsoil into a skin. It holds dirt against valley winds, traps ambient moisture, and fixes nitrogen for deep-rooted bunchgrasses. When cattle or machinery smash that crust, topsoil washes away and soil temperatures spike. Viral videos feature honeybee boxes, not cyanobacteria, preferring quick fixes over foundational architecture. We also misread ecological timing. Conservation metrics evaluate land during peak summer months, but in arid northern corridors, critical biological work happens outside that window. Early spring snowmelt provides 80% of soil moisture. Plants like yellowbell and balsam root bloom before summer heat hits 40 degrees, relying on native solitary bees that emerge for just a few weeks. By July, those pollinators have completed their cycle and died. To an observer in July, the land looks dormant, but the ecosystem operated on its own clock. Water management shows the same blind spot. Decades of drought response brought dams, reservoirs, and canals to keep surfaces green. But holding water in open reservoirs causes massive evaporation, while altering the soil moisture gradients solitary bees require for nest stability. Rapid flooding and desiccation, but semi-arid grassland is a masterclass in extreme adaptation. As summer droughts lengthen across Western Canada, these landscapes offer vital ecological blueprints. Native ground-nesting bees, wind-resistant biocrusts, and deep-rooted bunchgrasses are frontline survivors of environmental extremes. Dumping livestock or monocultures onto them disrupts the mechanisms preventing dry belts from becoming sterile deserts. Restoration looks like humble geometry, contour buns along dry ridges, beaver dam analogs in gullies, and baseline surveys to identify native species before trying to save them. On a global scale, the lesson holds. Just as dust from Chad fertilizes the Amazon, Canada's ecosystems rely on interconnected systems spanning continents, Pacific moisture patterns, continental migration corridors, and deep groundwater reserves. Treating landscapes as isolated reveals only the limitations of our vision. The desert was never waiting for shipments of bees or viral headlines. It has performed its quiet work on a clock indifferent to news cycles. Look past quick fixes to baseline data, native species, and the geometry of the land. The real science is stranger, more intricate, and far more rewarding than the myths invented to replace it. I quote him, Ambrose Wild. Thanks for watching. Subscribe to uncover the actual science shaping our planet's most misunderstood places. Because the world is full of forgotten landscapes, and we're just getting started.